This is cm2900 sample paper, question 1. We've got z equals 6x squared y plus x plus y to the 4 plus 3. We're asked to find the partial derivatives up to second order. So start with partial dz by dx. So x is the variable, anything else is a constant. So 6x squared y should be read as a constant 6y times x squared. Derivative of x squared with respect to x is 2x, so the derivative of 6y times x squared is simply 6y times 2x, because 6y is a constant. So we have 6y times 2x. Derivative of x with respect to x is 1, and the other two terms don't have any x's in them. Y to the 4 and 3 are both constants, so the derivative with respect to x is 0. Just tidy this up slightly. 6y times 2x converted as 12xy plus 1. That's the other part. Then partial dz by dy. It's now y that's the variable. So here 6x squared y should be read as constant 6x squared times y. Derivative of a constant times y is just the constant, so 6x squared there. X is just a constant, so it doesn't contribute anything. Derivative of y to the 4 is plus 4y cubed. Derivative of 3 with respect to y is 0. Then the second order derivatives, partial d2z by dx squared. So that's the derivative of partial dz by dx with respect to x. So we have 12xy should be read as a constant 12y times x. Derivative of a constant times x is just a constant, so 12y. And 1 is a constant, so its derivative is 0. Partial d2z by dy squared. So derivative of partial dz by dy with respect to y, partial derivative. Well, 6x squared then is a constant, so it contributes 0. Derivative of 4y cubed is 4 times the derivative of y cubed, which is 3y squared. 4 times 3 is 12, so it gives us 12y squared. And lastly, partial d2z dx dy. So we should look at the first two variables, z and x, tells us to look at partial dz by dx. The third variable y tells us it's a differentiation with respect to y. So derivative of 12xy plus 1 with respect to y is just going to be 12x, because we've got a constant times y. Derivative of a constant times y is just a constant, 12x. Derivative of 1 is 0.